Hello, Joanne Myers here with Clinical Calculations. This is Unit 4, Chapter 15, Reconstitution of Solutions. So you've got a vial of powder that sits on the shelf, has a longer shelf life. You have an order. You now need to make this vial of powder a liquid that you can either inject or put into an IV. So you're looking to reconstitute the solution. So you're most likely going to add sterile water to this vial. It will then have a certain concentration based on how much water you put in. Obviously, you put in a little water, then the amount, if you drop 1 milliliter of liquid, it's going to be more concentrated and more potent. If I put in a lot more water, then when I withdraw 1 milliliter of fluid from the vial, it will be more diluted. The strength will not be as strong. If you mix Kool-Aid for kids, then if you put in a lot of water, there you go. It's more diluted. If you put in less water, it's more strong. You can do this with any type of drink. Here we have on our screen, Chapter 15, Homework Part 2, Reconstitution of Solutions. The order is penicillin. So you are to get 950,000 units via IV every 4 hours into your patient. What you're given is this vial of powder. So you have to reconstitute the solution. I've flipped it around so it's a little bit easier to read. Try and make it a little bigger. So each vial contains penicillin G potassium, equivalent to 5 million units. So there are 5 million units of medication in this vial here in powdered form. Each million units contains approximately 6.8 milligrams. So 1 million units, and never abbreviate units with a U, is the same thing as 6.8 milligrams of sodium and 65.6 milligrams of potassium. This is actually not information that you'll likely to use, but I'm trying to differentiate what's going on here. All right, your usual dosage, see the package insert. Okay, the manufacturer of this medication is going to give one set of directions and 3 or 4 or more options. If you need to look at your order, again, this is how many units we need. So looking at these 3 options down here, go with the highlight, 250,000, 500,000, or 1 million units per milliliter. We want to inject as little medication into our patients as we can. Now, the order says we have to get 950,000 units into our patient. We're going to choose the last option, the 1 million. You want the option that is closest to and larger than the order. So if 250,000, 500,000, or 1 million, which number is closest to and larger than what is ordered? Well, the only option there, that's too big. The only option there is the 1 million units. So the amount of diluent that will be added is 3.2 milliliters. This is the amount of diluent, the amount of liquid you're going to put into the vial. And after you put it into the vial, so that's not going to be used. The important part is 1 million units will be the same thing as 1 milliliter. And where do I get that? Right here. Because we're going to put 3.2 milliliters of sterile water, or whatever it says here, see package insert. All right. Next question. So, what is the amount in each vial? In this case, it was our 5 million units. How much diluent should be added? We're going to add 3.2 milliliters. Once I've put that 3.2 milliliters in, then I need to read the directions and see how much liquid will that make. All right, it's not going to stay in this case. What's the appropriate concentration after reconstitution? My 1 milliliter will give me 1 million units. So now, what's the dose for this order? The order, it's not on the package insert. The order is our 950,000 units. To use dimensional analysis, I will use this equivalency statement, 950 units times a value of 1. So if I put my units in the denominator, that means I will have milliliters in the numerator. So my 1 milliliter will be 1 million units. So that will be all right. Now you can see the original order was down here. 950 units is how many you need to get into your patient. So in order to get that amount of medication into your patient, you will need to put into the IV 0.95 or 95 hundredths of a milliliter. Again, this 3.2 milliliters that you're adding to the vial is a liquid to turn the powder into a liquid. So then you can use your needle to withdraw, or your syringe to withdraw 0.95 milliliters. That's what you will inject into the IV bag. And then in Unit 5, you'll learn how to set the pump so that the IV fills and injects your patient with the right amount of medication at the right rate or speed. Keep the questions coming.